Okay, just a couple of quick questions here from the practice test. First, we have find the values of x such that f of g of x equals 19. Now, we've already found f of g of x. We've found this function in a part 2. And that's this here, 2 and then in brackets x squared plus 2, and then take away 3. That whole thing there is f of g of x. And what we're doing is we're going to find the values of x when it equals 19. So the first thing I've done is plus 3 to both sides. That's going to get rid of this 3, okay? And on the right-hand side, we'll have 22. Then what we're going to do is we're going to get rid of this 2 out the front by dividing both sides by 2. Okay, if I divide both sides by 2, the left-hand side is going to become x squared plus 2. The right-hand side becomes 11. Then we'll take away 2 from both sides to give us x squared is 9. And then we square root both sides to get x is positive 3 or negative 3 as our solution. All right, keep moving along on to the next one. We have f of g of x equals g of x. So what we're doing here is we're going, well, we know f of g of x from a part 2 and from the previous part as well. It's 2, this equation here. And then we have a look at the right-hand side. We're going to equate it to g of x. That's our g of x function. Now what we're going to do is we're going to try and solve this equation. We're going to try and solve it for x. So the first thing I've done is expanded this bracket. So I've got 2 times x squared, 2x squared, and 2 times 2 gives me positive 4. And then that take away 3 still hanging out there. Next, what we'll do is collect those like terms. All right. Or even then what I've done is I've taken away x squared from both sides and taken away 2 from both sides. Okay, so if I take away x squared and take away x squared, on the right-hand side it cancels. On the left-hand side we have 2 lots of x squared, take away 1 lot of x squared, gives us 1 lot of x squared. That's what this term is here. Then we take away 2, so we have here positive 2. And if we take away 2, well, I've written it as 4 take away 2 is 2, and then I still have the minus 3 hanging out. Now, 2 take away 3, we can collect that. That'll be minus 1. Then what we do is we go plus 1 to both sides. All right, so if we plus 1, we'd have x squared is 1, and then we square root both sides to get x is positive or negative 1. Okay, then the third question was about this function and how to draw the sign diagram for it. Now, the first thing is that with this kind of equation, what you'll be doing mostly is looking at the graph from the calculator. So I've gone ahead and graphed it in Desmos. Here's what the graph of it looks like. And we can get the roots from the graph. Okay, so we can g-solve the roots. So we have an x-intercept at minus 2 and an x-intercept at 1. So that's displayed there and there. The asymptote, you can observe it. Okay, you can observe the asymptote there. You can see that it's going all the way up here and all the way down there. But it's not something that we can g-solve as such. So the way we do it is with this type of function, we say that the roots occur when the numerator is 0. All right, so notice how I've made the numerator equal to 0 there and solved that, and those are the roots, and we can g-solve those ones. Whereas the asymptote occurs when the denominator is 0. So what I've done is I've made the denominator equal to 0, solved for x, and that's where the asymptote is. Okay, so there's an asymptote at x equals 3. And then all we're doing for the sign diagram is indicating when's it above, when's it below. So what we can see is that to the left of, if I just scroll down a little bit more, to the left of minus 2, so here's minus 2, and to the left of minus 2, it is positive. It's above the x-axis. In between minus 2 and positive 1, it is below the x-axis. So it's going to be negative over that point. And in between minus 1 and the asymptote here, displayed in blue, it is positive, it's above. And then after the asymptote, it's always negative. Okay, so that's those 3 questions there.